what is an increasing or decreasing function? So here we have the definition. A function f of x is increasing on an interval if we have that f of a is less than f of b for all a and b in the interval. Okay, this a and b have to be in order, a less than b. So with the picture, this is going to be much more clear. So we have that the function is increasing, okay, if I have a and b and my f of a is smaller than my f of b. Did you notice here? A is smaller than b, f of a is smaller than f of b, and the function is clearly increasing. The values get larger and larger. On the other hand, a function is decreasing, so this one is increasing. A function is decreasing, that means that if I have a and b, a less than b, the value of f at a will be larger than the value of f at b. Okay, that means that as I move towards infinity, the value of the function decreases. As I move towards the right, the value of the function goes down. So that is what decreasing means. But mathematically, we write it like this. If a less than b, then f of a bigger than f of b. Okay. But this doesn't look very easy. So there must be some easy way to tell if a function is increasing or decreasing. Actually, we can use derivatives for that. So if we have f prime of x that is positive on an interval, then f is increasing on that interval. Okay, so we only need to check if the function has positive derivative, of course, if it's differentiable. If it does, then it's increasing. And of course, if the derivative is negative, then the function is decreasing. On that interval. Okay, so we have both increasing and decreasing. This is very easy to remember. You just need to think about the function f of x equals x. Okay, how does this one look? This one is increasing and it has derivative which is positive. And if we think about f of x equals negative x, the derivative is negative, and of course it's decreasing. Okay. Now, whenever we want to find the intervals where the function is increasing or decreasing, we need to be very careful and methodical. Okay, so for that we use what is called sign charts. Okay, these are going to be our friend for the rest of the semester. So we need to learn to do sign charts. What do I mean by that? Let's do an example. X to the power 4 minus 2x squared plus 3. And here we want to make a sign chart for the derivative. And then we will try our luck with graphing the graph of the function f. So to make a sign chart, first thing we need to do is to compute the derivative. So it's 4x to the power 3 minus 4x, and that's it. The plus 3, when we take the derivative, disappears. That means for x times x squared minus 1, that is for x plus 1, x minus 1. And now the question is this positive? Is this negative? Is it 0? The values for which these derivatives are 0, they are clear. They are the roots, right? It's going to be 0, -1, and 1. But these are more interesting because the answer is, well, it depends. So let's see how we can find that. So first, we are going to put on a line the roots, right? 0, -1, and 1. And then what we are going to do is to check what is the sign of the derivative to either side of these values. So if I look at values that are less than -1, okay, how is x plus 1, and how is x minus 1? So when I'm looking at these values that are less than -1, right, my x is, well, less than -1, so in particular it's negative. X plus 1, the largest it can be is when x equals -1, so this is going to be less than -1 plus 1, which is 0. So it's negative. And x minus 1, no chance. We are looking at negative numbers here, right? So if I subtract something, then it's even more negative. So all three of them are negative. And what happens when we multiply three negative numbers, as we are doing here? X is negative, x plus 1 is negative, x minus 1 is negative. So it's minus times minus plus times minus minus. So we have that f prime of x is negative. And therefore, f is decreasing. Okay. So we are done with this, with the first one. Let's move on to the next interval. In the next interval, from -1 to 0, what is going to happen? So x plus 1, x minus 1. So x is still going to be less than 0 because we are on the left of 0. But now x plus 1, if you notice, what is the smallest it can be? So the smallest will be, x plus 1 will be the smallest when I put x equals -1. Okay, then -1 plus 1 will be 0, right? But then as I move up, for example, -1/2 will give 1 minus 1/2, which is positive. Okay, so what do we have here? We have a positive number. And x minus 1 still, because we have x that is negative and we are subtracting -1, it's still negative. All right, so we have a product of two negative numbers and one positive number when we look at the derivative. So that means negative times negative, positive times positive, positive. So because the derivative is positive, we have that f is increasing. Okay, 2 out of 4. X plus 1, x minus 1. Let's check again. So now, because we are on the right of 0, right? We are on this interval from 0 to 1. X is positive. X plus 1, it's a positive number. I'm adding something positive, plus 1, so it's even more positive. And x minus 1, this one is negative, right? Because any value of x in this interval is going to be between 0 and 1. So since I'm subtracting -1, I'm subtracting 1, then I will always be negative. Okay, for example, I take x equals 1/2, right? I take -1, I get -1/2. So now I have x times x plus 1, x minus 1, and I have 2 positive and 1 negative. So it's positive, positive, negative. So f prime of x is negative. So f is decreasing. And then the last one, x, x plus 1, x minus 1. In this case, x is obviously positive because it's bigger than 1. Because it's positive, if I add 1, it's even more positive. And now even x minus 1 is positive because I have numbers that are all larger than 1. So x minus 1 will be always positive. So all three of them are positive. That means the derivative is positive and the function is increasing. Okay, so notice what happens here. We have decreasing, then increasing, then decreasing, then increasing. So what can we say about the critical numbers? So x equals -1. If before x equals -1, I'm decreasing, and then as I leave, I'm increasing, what is that point? It's a minimum, okay? Then x equals 0, I arrive increasing and I leave decreasing. So it's going to be a maximum. And x equals 1, I arrive decreasing, I leave increasing. So it's going to be a minimum. Okay, so this is very important. We can, from the sign chart, we can always figure out, okay, just by inspection, what type of extrema do we have? Okay, let me take note of what we did here. F prime of x switches from negative to positive. Then we have a local minimum. Okay, and if we have that it switches from positive to negative, then we have a local maximum. Okay, and with this information, we can really sketch the function because all we need, we have the 3 critical points, right? What that will do. And we have the values at the critical points. That's not going to work. -1, 1. You have the values at the critical points. Let's look at the function f. Okay. So at 0, I have a value of 3. At 1, I have 4 minus 2 makes 2. And at -1, I have 1 minus 2 plus 3, that makes 2. Okay, so I have these values here. And then looking at the sign chart, and then we can just trace the function. It will look something like this. Okay, so we have 2 local minima and 1 local maximum. And then we have the intervals where it's increasing or decreasing.